Welcome back. Today I'm going to be talking about how to convert decimals and percentages into fractions. So, in order to convert a decimal into a fraction, we need to check the place value of the final digit to determine the correct denominator. So, I want to get into a bit more detail about what I mean by that. We're going to have something like this. We're going to have a number and then point and then some other digits potentially. This first digit is right after the decimal place is the tenths digit. And so therefore the denominator, if the final digit is in the tenths digit, would be 10. Then we have the second place value, which is the hundreds. And if this is the final digit, right, if the final digit is two places after the decimal, if there's two digits after the decimal that are not zero, or I should say if the final one is not zero, then the denominator would be 100. And likewise, this one is the thousandths. So if this is our final non-zero digit, then therefore the denominator would be 1000. And then if the fourth one is our final non-zero digit, it would be 10,000. And this pattern does continue beyond this. In general, our denominators will just stick to these four, but if we do end up with even more places after, we just continue to follow this pattern by adding another zero to our original number. Then for a percentage, we use 100 as the denominator. So we take the percent sign away, we put over 100 instead. And the last thing I want to mention is it's important to reduce the fraction if possible. Sometimes we'll be able to reduce the fraction, other times we won't be able to. And I'll get more into detail on how to reduce the fraction when we get into it. So here it asks us to convert the following from decimals into fractions. So for this first one here, I noticed that the last decimal point, the last decimal place here, is a 5, and the 5 is 2, 1, 2 numbers after the decimal point. That means we use 100 as the denominator, because as a reminder, we have this as denominator 10. The second one would be denominator 100. The third one denominator would be 1000. So for this one, for A, the answer would be 85 over 100. Now, can that be reduced? Yes, it can. And how do we know? Well, if there is a common factor between the numerator and denominator that is not 1, that means that the fraction can be reduced further. So in this case, I notice both of these are divisible by 5. The way I know that is because 85 ends in 5 and 100 ends in 0. And recall from the divisibility rules video that any number that ends in 5 or 0 is divisible by 5. So I'm going to divide both of these by 5. And if I do that, we know that 85 divided by 5 would be 17, and 100 divided by 5 would be 20. So therefore, 17 over 20 is the reduced fraction answer. And this cannot be reduced further because 17 and 20 do not have any common factors other than 1. All right, let's now do letter B. So for letter B, we have 0.372. So notice that we have three different numbers that are not 0, or I should say three numbers after the decimal place, and the last one is not 0. And so therefore the denominator here would be 1000, right? Because if we wrote this here, we end up with final digit 2, and so therefore we end up with using 1000 as the denominator. So that means that this fraction is 372 divided by 1000. Now, can we reduce this? I would say yes, we absolutely can. And here's how I know. Because in this case, I notice that the final digit of the numerator is a 2 and the final digit of the denominator is a 0. And recall that numbers are even, meaning they're divisible by 2, if they end in an even number, 0, 2, 4, 6, or 8. And both of these do. So therefore, we can divide by 2. So I'm going to do that. I will divide by 2 and get 186 over 500. Then I notice that we still have two numbers divisible by 2, so I'm going to divide by 2 again. And if I do that, I get 93 over 250. And that we probably can't really reduce any further because there aren't really any factors in common other than 1 here, and so we're good to go. To prove that, I'm going to actually do the factor trees for both of these to show that. So for 93's factor tree, we have, let's see, we have 3 and 31, and both of these are prime numbers. And 3 and 31, neither of those go evenly into 250, and that further proves the point that we cannot reduce this whatsoever. All right. Next, let's do C. So C is 0.9. So for this one, the final digit is right here in that first position right after the decimal. So therefore our denominator is 10. So the answer is 9 over 10. Now 9 over 10 cannot be reduced, and so therefore I'm just going to keep it at 9 over 10. So next let's do percentages. So for percentages, the nice thing is that the denominator is always just 100, right? Because what a percentage is just a fraction out of 100. So 47%, that's just 47 over 100. 18%, just 18 out of 100. And 50% is just 50 out of 100. And so these would be our answers for those ones. Now, the only other thing we have to consider is that we might need to reduce some of these values if possible. So 47 out of 100 actually cannot be reduced because 47 and 100 do not have any common factors other than 1. Whereas 18 and 100, well, those actually can be reduced a little bit because both of these have a common factor of 2. So if I divide both by 2, I get 9 over 50. Now 9 over 50 can't be reduced further because 9's only factors are 1, 3, and 9, and none of those other than 1 are factors of 50 as well. Then for 50 over 100, we can actually divide both by 50 to get that 50 over 100 is the same as 1/2. So that's the only extra step for that one, is make sure that you do reduce. But the nice thing about percentages is it just means the denominator is always going to be 100. So take away the percentage sign, add a denominator of 100, and you're good to go. As always, if you have any questions, feel free to leave those in the comment section, and we'll see you for the next one.